today's lesson we're starting off doing a quick review of square roots, and the reason we're doing this is because we will be using square roots when we start looking at calculations using the Pythagorean theorem. All right, so the square root of a number is one which when raised to the second power produces the given number. The square root, for example, of 25 would be 5, because 5 squared is equal to 25. 5 squared means 5 times 5. Let's put that down here. 5 times 5 is equal to 25. So when you take the square root of 25, the answer is 5. All right. Similarly, if we took 9 squared, that means it's 9 times 9, which is equal to 81. If we took the square root of 81, the answer is equal to 9. All right, now some numbers will have exact square roots, like 5 and 9, like we just saw, but some numbers we can only get the approximate value for their square roots. And sometimes these numbers there will be non-terminating, non-repeating decimals, and we call those numbers irrational numbers. So irrational numbers, these are the numbers that non-terminating, meaning they don't ever end, they just keep going and going and going, but they're also non-repeating. They're non-terminating and they are non-repeating. So they don't repeat. They are just random numbers that keep going on forever. So those are called irrational numbers. So for example, if you have your calculator, you could put in the square root of 29, and you will end up with a number like this, 5.38516.5, and it just keeps going. All right, there's no numbers that are repeating in here to make a pattern. They are random numbers, and so they're non-repeating and non-terminating, so this is an irrational number. A pi that you have used when working with circles is also an irrational number. It is a number that we're familiar with. We use 3.14, but it does continue on forever, and it doesn't repeat. The numbers don't repeat. So again, it's a non-repeating, non-terminating number. Another example is the square root of 73. You get 8.54003, and it does continue. And non-repeating and non-terminating. So when using the square root on your calculator, you will find it on your calculator. So on my calculator here, it is this button right here. All right, so next we're using the Pythagorean theorem, which was a squared plus b squared equals c squared. We're just looking at this triangle here. This side, which is 12 centimeters in this case, is the hypotenuse, labeled as C. This here is the side labeled A, usually the altitude, and then lowercase b is usually the base. But if you get those two mixed up, it's okay. It's the hypotenuse that you have to have labeled correctly. All right, so our first example we have here is a word problem. Calculate the hypotenuse of a right angle triangle where the base is 16 centimeters and the altitude is 12 centimeters. So a good idea always is to draw out your diagram of this triangle. All right, so there's my right triangle, and we know that the base is 16 centimeters. I'm going to label the base 16 centimeters. We know that the altitude is 12 centimeters. So like that. And we are trying to calculate the hypotenuse. So across from the right angle is our hypotenuse. So I'm just going to label it C. That's the one we are trying to solve for. All right, so using our formula that a squared plus b squared equals c squared, we can solve for c. So our a is 12 squared, plus b, which is going to be 16 squared, is going to equal to c squared. Okay, 12 squared, which is 12 times 12, that is 144. 16, which is squared, so 16 times 16, that is 256, and it's going to equal to c squared. When we add 144 plus 256, we get 400. So now what we have is that 400 is equal to c squared. So like we saw previously, we now have to take the square root of both sides to get the answer. All right, so if you take the square root now of both sides, we get the answer that 20 is equal to c. All right, so again, you have to use the square root here. Last step, square root of 400, which is equal to 20. Okay, which makes more sense. If you put 400 centimeters for this side, it's way too high because this is 12 and this is 16. Okay, so lastly, we would just have to write down our statement that the hypotenuse is 20 centimeters. Okay, next example, find the length of the altitude of a right triangle. Here is my right triangle, the altitude we are trying to find. We are given the base, where the base is 7 kilometers. So our base is 7 kilometers, and our hypotenuse is 25 kilometers. All right, again, make sure you have labeled it correctly. The hypotenuse is always the side across from the right angle. And A is the altitude. That is what we're trying to solve for. All right, so we'll start with our formula, which is a squared plus b squared equals c squared. So you have a choice now here. You can either rearrange the formula right away and solve for a squared, or you can substitute the values in and then solve for a afterwards. All right, so it's up to you if you want to subtract the b squared on both sides, like so, and then you get a squared is equal to c squared minus b squared, or you can just start your substitutions. All right, so let's start. I'll just start by doing the substitutions. So I'll just start here. So a squared plus b squared is equal to c squared. So that a squared is the one we're trying to solve for. Our b is 7 squared. And we know it's equal to 25 squared. All right, so that gives us a squared plus 49. 7 squared is 49. And then 25 squared, 25 times 25 is 625. All right, and then we can subtract the 49 on both sides. That leaves me with a squared is equal to 576. Okay. And the last step is taking the square root of 576, which gives me 24. Okay, so last step, we've solved for a squared, but we need to solve for a. You're going to take the square root of both sides. That'll give me a is equal to 24. And lastly, we will just write our sentence, which is the altitude is 24 kilometers. All right, you could have done it this way as well, where we had rearranged the formula right away. So here, we would have solved for a squared, which is 25 squared minus 7 squared. So a squared is equal to 625 minus 49, which is 576. And then you would take the square root of both sides, and a is equal to 24. All right, either way, you would still end up with the same answer. All right, so in this example, we are given the altitude, we are given the hypotenuse, and we are trying to solve for b, or the base. So a squared plus b squared equals c squared. And I'm just going to subtract the a squared on both sides, which leaves me with my formula that b squared is equal to c squared minus a squared. All right, so b squared will equal to 25 squared minus 20 squared. 25 squared is 625. 20 squared is 400. So we are left with b squared is equal to 225. After that, we're going to take the square root so that we get the actual side of b. So the square root of 225 is equal to 15. All right, so last is our final sentence, which is that, well, this is not a word problem, but we can leave it as. So we can leave it as 15 meters, or we can write our sentence that the base is 15 meters.